Welcome to True Projects. In this video, we are going to explain about a project titled A Variable Granularity Search-Based Multi-Objective Feature Selection Algorithm for High-Dimensional Data Classification. So now coming to the introduction part. This introduction sets the stage for an in-depth exploration of the variable granularity search-based multi-objective feature selection algorithm. Through its adaptive search strategy and multi-objective framework, this algorithm offers a promising avenue to address the challenges associated with high-dimensional data classification, propelling the field towards more effective and efficient feature selection techniques. As we delve into the mechanics and outcomes of this algorithm, we uncover its potential to revolutionize the way we approach classification tasks in complex, information-rich datasets. By dynamically adjusting the search granularity, the algorithm strikes a balance between exploration and exploitation, effectively managing the trade-off between exhaustive search and efficiency. So now coming to the objective part for this project is to contribute to the advancement of high-dimensional data classification techniques. By integrating multi-objective optimization and variable granularity search, it seeks to provide a sophisticated tool for feature selection that is both effective and enhancing classification accuracy and efficient in managing computational resources. This adaptability enables the algorithm to efficiently explore the vast feature space, adjusting its search strategy as it encounters different data patterns. The objective of this adaptive approach is to ensure that the algorithm efficiently explores feature subsets, avoiding exhaustive searches that can be computationally infeasible for high-dimensional datasets. So now coming to the requirements part, we have two types of requirements, that are hardware requirements and software requirement. In hardware requirement, operating system as Windows is required, processor i5 and above, minimum 4 GB of RAM is required, hard disk 20 GB and above. Coming to the software requirement part, Python IDE and that is 3.7 version is required. So now coming to the methodology part, first upload high dimension dataset. Uploading a high dimensional dataset involves providing the algorithm or software with the raw data that you intend to analyze. In the context of the discussed algorithm, this dataset likely contains numerous variables or features and corresponding samples. Second, pre-process and features correlation. Before running any algorithm, the dataset often requires pre-processing. This includes steps like handling missing data, normalizing or scaling features, and removing noise. Additionally, exploring the correlation between features helps to understand how they relate to each other and whether they provide redundant or valuable information. Correlation analysis aids in selecting meaningful features and can influence the subsequent steps of the algorithm. Third, run PSO algorithm. Particle swarm optimization, that is PSO, is an optimization technique inspired by the behavior of birds flocking or fish schooling. In the context of high-dimensional data classification, the PSO algorithm aims to optimize feature selection. It evaluates different subsets of features to find the combination that maximizes or minimizes an objective function accuracy while minimizing feature count. Running the PSO algorithm involves initializing a swarm particles which traverse the feature space to find optimal feature subsets. Fourth, run proposed VGS MOEA algorithm. The variable granularity search-based multi-objective feature selection algorithm, that is VGS MOEA, is the algorithm of interest in this context. Running this algorithm involves applying the specialized method to the dataset. The algorithm combines a variable granularity search approach with multi-objective optimization to efficiently navigate the feature space and select feature subsets that balance accuracy and simplicity. Fifth, comparison graph. Creating a comparison graph involves visualizing the results obtained from running both the PSO algorithm and the proposed VGS MOEA algorithm. This graph would depict how the algorithms perform with respect to the objectives such as accuracy and feature count. It helps to visually showcase the effectiveness of the VGS MOEA algorithm compared to the PSO algorithm. This graph is crucial for conveying the advantages of the novel approach. So now coming to the execution part. To execute the project, first we need to open the code folder. So here we have a folder which is named as dataset. In this folder we are containing some dataset over here. This is the main Python file which is containing the Python script in it. And this is the dataset which is named as report over here. This is the run.bat file. Instead of executing the program in command line interface, we created Windows bat file to execute the project. So now to run the project, double click on run.bat file to execute the project. So here this is the graphical user interface. With this we are interacting with the program. So now click on upload high dimension dataset button to upload the dataset for getting the output. Here I am selecting this dataset and now click on open button to upload the dataset. So here on this screen dataset loaded, and now click on pre-process and features correlation button to normalize and calculate features correlation. So here on this screen you can see that correlation value is calculated, and now click on run PSO algorithm button to run PSO algorithm and to calculate its accuracy. So now here on this screen in first two lines we can see total features available in dataset, and in second line we can see total number of features selected by PSO, and in third line we can see total time taken by PSO to select features, and in remaining lines we can see accuracy and other metrics. So PSO accuracy is 69%, and it took 22 seconds to calculate features, and here on this screen we can see PSO confusion matrix graph. So here x-axis represents predicted labels, and here y-axis represents true labels, and blue boxes contains incorrect prediction count, and yellow box and light blue box in dialog box represent correct prediction count. So we can see feature selected by proposed MOEA, and we can see it took execution time as 9 seconds, and we got its accuracy as 87%. And in confusion matrix graph we can see more number of records correctly predicted by proposed MOEA algorithm. So by closing this graph, now click on run proposed VGS MOEA algorithm button. So here you can see that we have got a confusion matrix graph for MOEA, and we can see it took execution time as 9 seconds, and we got its accuracy as 87%. And in confusion matrix graph we can see more number of records correctly predicted by proposed MOEA algorithm. And so now closing this graph, now click on comparison graph button to get the final graph. So here on this graph you can see that x-axis represents algorithm names, and here y-axis represents accuracy and other metrics in different color bar, and in both algorithms proposed MOEA got high accuracy and precision. Similarly you can upload and test with other datasets. So now closing this graph. So now coming back to the conclusion part, in essence, the variable granularity search-based multi-objective feature selection algorithm for high-dimensional data classification extends an invitation to researchers, data scientists, and practitioners to embrace its adaptive strategies and multi-objective focus. By doing so, they can harness the algorithm's strengths to address the inherent challenges posed by high-dimensional datasets, propelling the field forward and illuminating new avenues for data-driven insights and applications. This holistic approach recognizes the importance of striking a balance between predictive power and model simplicity, a balance that is paramount for actionable insights and model understanding.
For updates on latest project videos, please visit True Project's YouTube channel and subscribe.